Let's talk about rest energy. There are the two other types of energy which are part of mechanical energy. This is the part that's not part of what's generally considered mechanical energy. So we have kinetic and potential. Rest is the third kind, and pretty much all energies fall into one of these three categories. So rest energy is the energy an object has just because it has mass. Kinetic energy is the energy an object has because it's moving. Potential energy is the energy an object has because it takes work in order to put it in a particular position. Now the formula is very familiar to most people, the fact that E equals mc squared. This is a little bit different than the famous formula E equals mc squared, and the fact that this is m sub 0, which is a reference to the rest mass. And the rest mass is the mass an object has when it is at rest relative to the observer. Now in everyday speak, it's the mass of the object. It's just that the mass of the object changes the faster it goes. It's not really noticed until it is more than 10% of the speed of light, but at that point, you're now considering what are called relativistic speeds. So if I take an object and I put it on a balance to find its mass, that balance is at rest relative to me. That is the rest mass. If I had a collision experiment going on in class, that's the rest mass we're dealing with. It's slightly off the rest mass, but there's no device that we have that can measure the difference between that mass and the rest mass, so we consider that the rest mass. So in the formula, we have the rest mass times speed of light squared, and the speed of light is exactly this number right here, the 299,792,458 meters per second. That is exact, but as far as what we're concerned, in most classes, 3 times 10 to the 8th meters per second is sufficient. Just run through an example. I weigh 200 pounds. So the first thing I do is to get it in terms of newtons. So I do the conversion factor. And then I need to figure out what my mass is. So I take that weight of 200 pounds in 889.644 newtons, and that's equal to mg. Now I'm living in Winston-Salem, and that's the acceleration due to gravity in Winston-Salem. I divide by that value, and I end up with a mass of 90.8 kilograms, which is my rest mass. Then I plug it into the formula, 90.8 kilograms times the speed of light squared. I went ahead and used the exact number and rounded at this point. And so I have 8.16 times 10 to the 18th joules. Give it some context there. I went ahead and multiplied by the conversion factor of kilowatt hours from joules. So converted into kilowatt hours. Now, if you look at the total energy use by the US in 2020, this would cover 60% of the entire country for a year if somehow my mass could be completely turned into usable energy. Now, as we potentially know from the second law of thermodynamics, there's going to be a loss no matter what. It's impossible to do it. And right now, we definitely don't have the technology of converting a human into pure energy that is usable. However, if it were possible, I could supply the energy needs of 60% of America for a year, or every American for 60% of the year. Or I could take just one average household, and this is the 2017 average use per household, and run one household for 218 million years. So that's quite a lot of energy we have stored in mass. Now, we have, as mankind, have been able to harness some of that, and that is what we see in the atomic bomb and the hydrogen bomb. Anyway, there it is. Hope you're having fun.